I love this. This is amazing.
Thank you, Mr. Tang. Right, so there are
You're
two...
back with your boy, Mr. Wade, and this is YouTube Math. Boo, boo, boo.
We have an introduction. Thank you, Mr. Tang. As long as I can work out how to pop it on the start of this video, that's going to be our introduction from now on. What an introduction. Okay, today then we're going to look at equivalent fractions, decimals and percentages. Again, we're just building on from the work we've already done this week, and hopefully it should be fairly, not necessarily easy, but fairly logical, as it is a clear progression. But first of all, I've got a little joke for you. Why was the fraction apprehensive about marrying the decimal? Because he would have to convert her. It's such a bad joke. It was along the same lines as what work we're doing, so I thought, why not? I would say it. So today, like I just said, we're looking at equivalent fractions, decimals, and percentages. I'm going to work off a piece of paper, as I think that's how most of you are going to be working at home. First of all, let's start. It says circle the odd one out. We've got 0.76, we've got 38%, and we've got 38 out of 50. So I've chucked them down on a piece of paper. 0.76, we said if it's 1.00, that'd be 100 over 100, etc. So that'd be one whole. And 100 over 100 is also a whole. So this one here, we can pop it into a fraction. We've got 76 over 100. 38% per cent. Cent means out of 100. So we have 38 out of 100. Ooh, two different ones straight away. We've got 38 out of 50. Now we need to get this denominator to 100. So what we can do, times 50 by 2 to get 100, times our numerator by 2, 38 times 2, do it in column addition if you don't know off the top of your head. That is 76 out of 100. 76 out of 100, 38 out of 100, 76 out of 100. So I think it says circle the odd one out. Today we're going to circle 38% because that's the original question. This is our working. So 38% in this starter. Perfect. Hopefully that won't take you too long. Next, we've got to circle the equivalent fractions. Now this gets a little bit complicated. So this is the main thing that I want you to listen to today. So I've again written it down here. Now we've got 756. Okay. We need to try and make all of these, well, similar denominators. But first of all, we've got 7 as a numerator. We need to try and get that down to 1. So we can simplify this fraction here. What we mean by simplifying is we're going to get the same fraction into its simplest form. So the way we would do that, we would look at the 7 as that's the numerator. How many 7s go into 56? So if you need to, we'll do a bit of division. How many 7s go into 56? How many 7s into 5? 0. How many 7s into 56? 7 times table. Or if not, you could have just written down your 7 times table. 7, 14, 21, 28, 35, 42, 49, 56. So 7 times 8 is 56. So if we found out that it's we're dividing by 7 to get 1, so 7 divided by 7 give us 1. 56 divided by 7, we've just said was 8. So that 756 is equivalent to 1/8. Go across here. We can divide numerator by 4, so we get 1 as our numerator. 24 divided by 4. 24 divided by how many 4s going to 20? Well, I know 5 times 4 is 20. So now we just need to add another 4. And so 6 times 4 would be 24. So that is equivalent to 1/6. Over here, we've got 1/8. We don't need to do anything to that. Here, we've got 6 over 42. Again, we need to try and get 1 as the numerator. So we could divide by 6. That would give us 1 as the numerator. 42 divided by 6. Well, I know 6 times 6 is 36. If that's a square number. So now we need to just add another 6 on. So 6 times 7 would be 42. So this is where our times tables will come in handy. 9 times 72. Well, I know that 72 is in a 9 times table. 9 divided by 9. Just 1 as the numerator. It's the simplest form, remember. 72 divided by 9. Oh, that's 8. I know that just because I know my 9 times table. So if you need to work these out and go a little bit slower, absolutely fine. 3 times 24, the same thing still applies. Divide by 3 gives us 1 as our numerator. 24 divided by 3, 3, 6, 9, 18, or however you want to work it out. If you go through your times table, write it down if you need to, but the answer would be 1/8. Now, just because we converted them does not mean we have answered the question. So we go back to the question. It says, circle the equivalent fractions, plural. So it's going to be more than, obviously, 1. We need more than 1 anyway to be equivalent, but we've got 1/8. We've got 1/8. We've got 1/8. 1/8, 2 that just stand alone, 1/7 and 1/6. Now this is really important because it's all about simplifying fractions. We need to simplify the numerator to get it down to 1 if possible. Sometimes we won't be able to do that, but in this instance we would be able to. So that is the introduction done. Now if we're working through, the answers are here obviously, working through match the equivalent fractions, decimals and percentages. I think we'll be able to do that to get the numerator, the denominator to 100, so times it by 2, or times it by 20, times it by 2 to get to 10, then times it by 10, or just straight times it by 20. So 8 times 20 would give you 100, 4 times 20 would give you 80, 80 over 100. What does that match up with? So I'd have to go through this one. Make sure you're careful as well. Answers are here. Circle the equivalent fractions, decimals and percentages. This is where we're looking at all three. It's a bit more interesting, but again, it's just building on what we've done yesterday. What's 1/5 as a decimal? Not sure. Let's get it over 100. So 5 times 20 would give us 100. 1 times 20 would give us the numerator. Then we can see if it matches up with the other two here. But it says circle the equivalent fraction, decimal, and percentage. So to convert them all, so we can work it out and then go from there. That's varied fluency 2, the answer there. Varied fluency 3 is the next one I want to have a look at. True or false? 10/25 is equal to 0.25. Now, I've written that down here. 10/25. First of all, we know we need to get this out of 100. So, 25 times 4, we give it out of 100. 10 times 4 is 40. Is 40 over 100 the equivalent to 0.25? 0.25, 40 over 100. I'm not going to give you the answer. I'm going to give just leave that for you to work out. So we've worked it out. Are they the same? You need to be thinking about that. Now, as we go back to the PowerPoint, remember we don't have to go through every single slide, but you do need to get onto some reasoning and problem solving sides as well. We want 0.6 as a fraction and as a percentage. Take your time with this, don't rush this. 40 over 50 is a fraction, decimal, and percentage. Maybe pop that into it over 100. That would help you because decimals, 1 would be the equivalent to 100 over 100 in this instance, and percentages out of 100. So take your time with that. There's more to come in your questions later. Where are we looking now? I can't remember which one I said I was going to have a look at. Circle the odd one out. Same things what we've done earlier. So convert them all into, say, over 100 here, so we can get a clearer understanding, and circle the odd one out. But you need to explain your reason. This one's the odd one out because you need to tell me. Please don't just look straight at the answers. Have a go first and then look at the answers. I do believe this one here is quite good. Jacob eats 0.5 of the pie. What is 0.5 as a fraction or as a percentage? Because Alicia eats 20% of the pie. Greg eats 5/20ths of the pie. So you might want to put that over 100. Work out what that is in a fraction over 100. Work out what that is as a fraction over 100. Or put them all into percent or all into decimals. It's up to you. But who eats the most pie and who eats the least? So your names should come up there. Reasoning 2. This is the one that I just want to look at before we get going this morning. So it's got 40 over 50 is equal to 40% and equal to 0.4. That's what Lucy has said. Then we've got Michael saying 40 over 50 is equal to 80%, which is equal to 0.8. Question says, who is correct and convince me? I'm not sure. So this one here, all we need to do to start with, we need to get this out of 100 because percentages are out of 100, and we know that 1 would be equal to 100 over 100 in this instance. So let's go for times 2, because 50 times 2. Ooh, the sun's coming through. Great that the sun's out today though. would be 140 times 2 is equal to 80. That's all I'm going to do on this question for you, as it's the same that would be used down here as well. We don't need to work that out because they're exactly the same. 80 over 100, is that equivalent to 40%, 0.4, or is it equivalent to 80%, 0.8? It says, though, if you go back to the question, who is correct, and convince me. Reason to me why is either Michael or Lucy correct in this instance. Okay, and the answers are there to check, but please do have a go. Now that shouldn't take you too long to go through some of the slides on here, and after that we're going to be looking at your sheets. Now, I downloaded them already, they'll look exactly the same on the website. If we go up, this is what your sheets are looking like. Ooh, we've got all the way to the top. Varied fluency. Now this is what we always start on in class, so you should know this is what we start on, and we're on equivalent FDP, stands for fractions, decimals and percentages. Now it's just got a little bit here of what we the differentiation, developing expected greater depth, etc. So the first page here is hot and spicy. It's always going to fit onto one page, remember. Second page is mega hot. Third page is are you nuts. Now we are expecting you to do one of these pages. If you choose to do more, fantastic. You do not have to. I felt like the PowerPoint was okay, so I'm going to go for mega hot. So that's 5A, 6A, 7A, and 8A, or B if you'd like to do B. And why not? Let's do B, because B is slightly different, or not different, but we always go for A in class, basically. So match the equivalent fractions, decimals, and percentages. Hopefully you'll be able to do that. You can just write them down nice and easy, convert them so that the 5/20ths would be out of 100, the half would, if convert them if you need to, match them up. Circle the equivalent fraction, decimal, and percentage. That should be hopefully fairly straightforward. We've just been doing that in the PowerPoint this morning. So circle the equivalent fraction, decimal, and percentage. Yeah, so we just need to convert out of 100. So equivalent out of 100, so times the 5 by 20. That's the denominator times the numerator by 20. What would that be out of 100? Where would that fit, etc.? True or false? We've got 10 over 40 is 0.4. Starting point here, get everything over 100. Pop it over 100. What do we need to do? Times that by something. I'm not going to tell you what. Times this number by something to get it out of 100. Times the numerator by exactly the same. See if that is what you would have the answer as a decimal. And then complete the table below. Write the missing fractions. 0.7 as decimal. What's that as a fraction? Put it in any form. Okay, if the answer says that it's slightly different, have a look at yours. See if you've just got it in a slightly different form. Now, if we scroll down here, 5B, 6B, 7B, 8B, there are the answers. Okay, so make sure you're marking those after. Then there should be some time for reasoning and problem solving. So reasoning and problem solving. Oh, if we go all the way up to the top, my laptop's been annoying. Problem solving. Equivalent fractions, decimals, percentages. So that is today's work. First page is always going to be hot and spicy. Next page is going to be mega hot. Now, mega hot starts here on 4. This is what we need to be careful of. So it starts 4, 5, 6. That's it. 3 questions in reasoning and problem solving. That's all we are expecting you to do. Like I said, if you'd like to do more, then fantastic. Again, you just circle the odd one out. So you're converting all the time. It might seem a little bit tedious, but just keep going with it. You're converting, explain your reasoning. So which one's the odd one out and why? 3 gardeners are watering plants. Bill waters 0.2 of the plants. Helen waters 40%. Frank waters 20/80th. Who waters the most plants? Who waters the least plants? Well, that you just need to convert. Keep going, converting. 0.2 as a percentage. Helen waters, or that's already as a percentage. What's 20 over 40 as a percentage? That's interesting. You might need to, a bit of a hint here, convert down. So we've got 1 over something. So 20 over 80, like we said earlier, we need to convert that down. Maybe divide by 20, see what we get, and then get that out of 100 so it's easier to compare. And then, so if I scroll down, 6B, Sarah and Leon are comparing fractions, decimals, exactly the same as what we've been doing. It is just converting, so 60 over 80. You need to have a little look. What would that be? We know that 20 goes into both of them, so 60 and 80 are both in a 20 times table, so maybe we divide the numerator by 20. 80 divided by 20 gives you something as a numerator. 60 divided by 20 gives you something as a, that would give you denominator. 60 divided by 20 would give you the numerator. So maybe work the fraction out. Like I said, this will look slightly different. Then you need to times by something to get it out of 100 to see who's correct. Now, once you've done that, again, go down and mark your own work, please. You'll be able to spot your own mistakes. Here, what have we got going on? Let's have a look. Oh, look, I didn't get any of them right. Why is that? Go back through them if you have time. If you've done everything, then you've also got Times Table Rockstars. You've got the Enrich website under the useful links. But I'm aware this is a very long video today. I just wanted to go through it a little bit clearer. So, that is your maths work today. Have fun and stay safe, guys.